This is our meteorology experiment. This wooden thing is called a rig, which we put a protractor and a flashlight onto it at 90-degree angles. And we made a 1.5 centimeter square on it to make it easier to
concentrate.
Record the surface angle of the light, surface area. We put the paper under the flashlight at 3 different angles, 90, 60, and 30, and we recorded the points at which the square of light was being shown. Okay, our data collected. The surface area for the 90-degree angle was 10 and 9/16 inches squared.
We moved the rig at a 60-degree angle and wrote down our findings.
And the surface area for the 60-degree angle was 21.09375 inches squared.
And we took the rig, put it at a 30-degree angle, and wrote down what we saw.
And the surface area was 44.0520833 inches squared.
Our method. We went in a dark room and put a paper under the flashlight at one of the 3 angles and drew the square where the outline of it was on the paper. Changes in angles. As the angle got smaller, the square or the shape got bigger.
Assuming that the unit of light coming through the cutout represents a certain unit of energy, we believe the area which the flashlight is focused on, we would have the most light, whereas the areas farthest from the focus would have the least amount of light. For example, on the 90 degrees, if you turn on the flashlight, the area with the most amount of light would be the area in which the flashlight is pointing. And the area that would have the least would be like out here, where it's not really pointing. And same with the 60 and 30. Right there, and right there. And very little over here.
Alright, so over a long exposure of light rays, at which angle would have the highest temperature reading and why? So, say this is our rig here. At a 90-degree angle, it will have a smaller area, but it will be directly above whatever is beneath it. So the light will be more concentrated and will give it its highest temperature. Sort of like how the sun is giving off heat to the equator. It's more concentrated on the equator, no matter where, so it's always really hot. At a 60-degree angle, the light will be less concentrated and will be spread out among a larger area. So this will cause the temperature to be less than the one that is most concentrated, which is the 90-degree angle. Okay, and last, the 30-degree angle, somewhere all over here. The area will be at its largest, and the light will be even less concentrated than the 90 and the 60-degree angle. This will cause it to be its lowest temperature, because the more spread out the light is, the less energy and heat will be given off. Alright, so last is comparing this experiment to real-world factors, and what would cause the sun rays to strike the Earth's surface at different angles. Here is my Earth, and here is the sun. Alright, so the Earth's rotation and orbit around the sun would affect its temperature of the Earth and the varying points of it. The Earth's tilt. Okay, so say that it's in the wintertime, and this is Pennsylvania, right about here. We are tilted farther away from the sun. So the light will only be hitting certain parts of the Earth, and we will be getting hit with less of it, and so will the North Pole. So this will give the equator a warmer temperature at this time, and give most of North America and the North Pole really cold temperatures and less daylight. Okay. And the Earth's distance from the sun can also affect its temperature. So still, Pennsylvania is up here, as where we live, and so it's the middle of summer. And the Earth's tilt is now closer to the sun. It will be giving it a really hot temperature in all areas that are closest to the sun, and the places tilted away from the sun will be cooler, such as the poles.
Thanks for watching.